Hey guys, and welcome to your first lesson in 8th grade math, which is when we're studying translations. Okay, so our learning target today is to define, understand, and apply rigid motion transformations, specifically a translation. So if we take a look at our success criteria, we're going to define a few things. The two things we're going to define, or I should say three things, is the word translation, pre-image, and image. So keep an eye out for those in the intro to our first example. We're going to recognize and distinguish translations. So we're going to be able to pick out if a translation has happened. We're going to perform what's called arrow notation. That's going to help us in our future transformations. And we're also going to create translation rules and use the proper notation for that. I also have that we're going to perform translations as well. We're just going to do a slight translation, but tomorrow we're really going to hone in on translating figures ourselves. So let's look at the main idea here. It says a transformation is a change in position, shape, or size of a figure. A rigid motion is a transformation that changes only the position of a figure. So I have a little bit of a word tree I'd like you guys to write down. First word, we have transformation. Can't spell. Inside transformation, you have four other words. We have translate. We have reflect. We have rotate. And we have dilate. Okay, dilate. Okay, those are the transformations. The three we're going to focus on the next couple weeks are the rigid motions, which are these three. Translation, reflection, and rotation. Those are rigid motions, meaning they do not change shape or size. Okay, dilations actually change the size of a shape. You saw that in your transformation sort. Okay, the next word says an image is the result of a transformation of a figure. To identify the image of a point, use prime notation. So if I were to just plot some point down on a coordinate plane and call it A, and let's say it moved over here, okay, diagonally, I would say that this is A prime. Okay, the original point is going to be called the pre-image. Pre meaning before. And then the point where it goes to is going to be called the image. So let's take these ideas and go over a little bit of an introduction to the first example. It says a translation or a slide. Slide is our slang term for translation. This is a rigid motion that moves every point of a figure the same distance in the same direction. So if I were to label this triangle, let's call this A, B, C, I can see how it moves to their corresponding A prime, B prime, and C prime. So let's actually draw out the path. If I were to draw a path of how A got to A prime and follow the grid lines, I can see that it followed along here, and then it took a turn, and I can actually count the units. I see 1, 2, 3, 4, 5 units right, and I see 1, 2, 3, 4, 5 units down. Now, right is a positive direction, so this is actually like a +5. Down is a negative direction, so this would be like a -5. So I end up going right 5 and down 5. I can double check that for all of the other coordinates. So from B, if I trace its path to B prime, I get another 5 units right, 5 units down. And then if I trace the path from C to C prime, I get another 5 units right and 5 units down. So notice how all three of the points travel the same distance in the same direction. That's what a translation is all about. So let's apply this in our first example. It says circle the transformation that is a translation. Then describe in words the translation that maps triangle ABC to its image A prime, B prime, C prime. Now, I'm going to give a reason as to why I would eliminate each of these answers. The very first one I see is a mirror image. Mirror image. Okay, I'm not looking for it to look like it's in a mirror. I'm looking for it to be oriented the same way. I'm actually going to make a note of that. Oriented the same way. So that's saying no flipping or turning. If you see any flipping or turning, the orientation has changed and is not a translation. So this first one is not a translation. We also should not see the shape changing size. That's going to be a dilation, which I see in the second one. This one changes size. So it's not that one. Lastly, I would say the third one is a translation. We also want to describe in words what has happened. Start your pencil where it says A, not A prime. The leftmost picture is not always going to be where you start. You're actually going to start over here because that's where it just says A and not A prime. So as you can see, in order to get to A prime, you actually have to move left 3 units, left being a negative direction, and then you have to go down 1 unit. So down meaning, again, a negative direction. So to describe that in words, I would say that we translate 3 units left and 1 unit down. That's our in-words interpretation. So our translation was the third image, and we translated 3 units left, 1 unit down. I want you guys to give this a try in your U-Try. Pick out which one of these is a translation, and then also if you could please add on in what direction and how many units you had to move each point to go from its pre-image to its image. All right, so here's another little intro to example 2. It says in triangle A prime, B prime, C prime, that's the image of triangle ABC after a translation of 2 units right and 3 units down. Okay, 2 units right, 3 units down. Let's actually look at the pathway from A to A prime. I can see I would have to go 2 units to the right, so that's a positive 2 units, and then 3 units down. Okay, and that would be the same for all of the vertices. I'm seeing 2 units right and 3 units down to go from each of the corresponding points. Well, if I were to write arrow notation, all I'm really doing is I'm recording down all the pre-image points. Okay, I'm putting an arrow in between, and then I'm writing all the image points. That's all arrow notation really is. Okay, and you should kind of be seeing that +2 and that -3. Take, for instance, if we look at -4 to -2. Those are both the x values from A to A prime. Well, -4 plus 2 is equal to -2. So in order to go from here to here, you had to add 2. Well, that looks very much like 2 units to the right, adding 2. Same thing would go for if we looked at the y values. Okay, if I look at the y values now, 1 to -2, well, 1 minus 3 is equal to -2. So in order to go from 1 to 2, we had to subtract 3. And that is actually just like the 3 units down part. So in the arrow notation, you should be able to see what it's doing to the points in words, as well as seeing it in the actual graphical representation. So let's actually try this in example 2. It says the vertices of triangle ABC are 1, 4, -1, 2, 3, and 3, -2. We're going to graph ABC and its image A prime, B prime, C prime after a translation 5 units left and 1 unit down. Then we're going to use arrow notation to show how each vertex of triangle ABC maps to its image. So first, we need to get plotting the original points. Again, look left and right first, then up and down. A is at 1, 4, so that's right there. Make sure you label. B is at negative 1, 2, right there. And C is at 3, negative 2, right there. Connect your dots so that you can see the triangle. And now we're actually going to perform the translation. Okay, 5 units left and 1 unit down. I'm just going to put like a dotted green line here. You don't even have to draw this dotted green line. If you don't want to, you can just make your pencil hop from grid line to grid line. Okay, but I'm going to trace the path so that you guys can see where the points are moving. So start your pencil at A and then count 5 units to the left. 1, 2, 3, 4, 5. And count 1 unit down. That's where A prime should go, right there. Let's do that again for B. Count 5 units to the left and 1 unit down. There's B prime. One last vertex, 5 units left and 1 unit down. There's C prime. Connect your dots to show the 2 triangles. You can see that they are the same triangle. They're oriented the same way. They're just shifted, 5 units left and 1 unit down. Last thing it asks us to do is to use arrow notation. And I literally am just going to write down what the original points were, which they've already told us up here. So A was 1, 4. B was negative 1, 2, and C was 3, negative 2. Put an arrow between them, and then you have A prime, B prime, and C prime, and I'm just going to read where the points went off the graph. So A prime ended up at negative 4, 3. B prime ended up at negative 6, 1. And C prime ended up at negative 2, negative 3. There's our arrow notation. I'd like you guys to give this a try in your second U-Try. The vertices are listed and they're already graphed for you. Translate the figure 4 units right, 2 units up, and then tell me what the coordinates of K prime are. Alright, so I've got another little intro here before your third and last example. It says you can also use arrow notation to write a general rule that describes a translation. For example, the point xy goes to where x is added 4 and y is subtracted 2. Shows an ordered pair xy and describes the translation 4 units right and 2 units down. So let me show you how you're going to write this rule. Okay, anytime you're going to write a rule, I'm going to write in black what you're always going to write. You're always going to write x, comma, y with an arrow. And then I write a parenthesis with an x, and I'll leave a little space. I'll put the comma, my y, I'll leave it a little space, and I'll end the parenthesis. That's how all of your rules are going to end up. Now, what goes inside those spaces depends on which direction the points are going and how many units. So let's say instead of 4 units right, which corresponds to the +4, and the 2 units down, which corresponds to the -2, let's say we were to do left 7, up 4. Well, left is like negative, up is like positive. Left and right goes with x, up and down goes with y. So I should have x -7 and y +4. So the words interpret to what goes inside of the parentheses. Okay, and the rule will always be set up the same way. X comma y goes to x with something added or subtracted from it, and y with something added or subtracted from it. So let's apply this in our third example. It says ABCD is a parallelogram. Use arrow notation to write a rule that describes the translation of A, B, C, D to A prime, B prime, C prime, D prime. Okay, so first I'm going to take note of how many units and in what direction you have to go from A to A prime. And then I'm just going to double check that from B, C, and D. Now be careful. The leftmost image is not, or the leftmost figure is not always the pre-image. If you notice, the blue figure has all the primes on it. So that's the image. That's where it's moved to. It's moved from the black image. So I'm actually going to trace from A, which is left. Oop, didn't mean to move my picture. Okay, it's actually left 1, 2, 3, 4, 5 units. Left 5, and then down 1. Okay, so left 5, down 1. I'm going to double check that with all the others. I'm seeing again left 5, down 1. Left 5, down 1. And left 5, down 1. Okay, so since it's all the same, I know, yes, this is definitely transformation. They didn't make any mistakes. And I can see that I should be subtracting 5 from the x, and I should be subtracting 1 from the y. So again, start off just by writing what you should always write. X comma y in parentheses with an arrow. In parentheses again, x, leave a little space, comma, y, leave a little space, and the parenthesis, and then just fill in the directions. So we went left 5, that goes with the x part. So minus 5, and then minus 1. The down 1 goes with the y, so y minus 1. There is our rule, our translation rule. Let's have you guys give this a try in your last U try. It says PQRS is a parallelogram. Use arrow notation to write a rule that describes the translation of PQRS to P prime, Q prime, R prime, S prime. Please answer the following 2 questions on your guided notes, as well as typing in your response into the Edpuzzle. These answers are going to be checked by Miss S or Miss Doring, and they are going to play a role in different groups you may be placed in, or it's also going to tell us how well you understand what you just learned. So if you are having trouble with how to phrase your answers to these questions, make sure you raise your hand and get some help. All right, well, I guess that pretty much wraps up our first lesson. Just to recap what we did today, we defined translation. We did that in the key idea, but we also applied it in example 1. We defined pre-image and image as well in the key idea and in example 1. We also recognize and distinguish translations from other transformations. All of that was basically summed up in example 1 and the key concept. Okay, I'm going to write KC for key concept. We also performed arrow notation. That was actually in example 2. And then we also created translation rules and proper notation in example 3. Now, as I said in the beginning, we will be doing more of number 6, performing translations, which we did a little bit of today, but we're going to be doing more of the hands-on performing of translations come tomorrow. So you may go ahead now and start your homework.